Hi, my name is Florian Nalami and thank you for joining my webinar on 7 ways to get more out of your Adapt Builder with Visicon. Visicon is a general BIM model review and checking solution that provides a common 3D model interaction solution for structural engineering offices, leading to smarter and more efficient decision making. Today's webinar will review 7 ways you can use Visicon to get more out of your Adapt Builder models. As I present Visicon, you'll see that it's a BIM toolbox that offers different functionality, and what I'm going to do is pick and choose from different of the available tools to help you kind of get the most out of your Adapt Builder models. And we're going to do that by going through 7 very specific workflows and examples. In each case, we're going to be referring to the Adapt Builder model. And when I refer to the Adapt Builder model, really what we're saying is that I would have gone into the Adapt program, and so here you see a screenshot, and under File, I would have used the option to export as a Visicon BIM file. This exports the Adapt model in the Adapt Exchange INP format, and that's going to be the basis of each one of our workflows. The first workflow we're going to go through is how to use Visicon to jazz up your reports. And really the scenario is where you're trying to put together a calculation package, or you're just putting together a project proposal to win a new project, and you've put together an Adapt Builder model, and you want to kind of highlight what you've done, all the great things in your Adapt model in this report. So you just out of the box, you can use Visicon to create better 3D images. Besides just the raw 3D better images, you can cut lots of different sections much easier, and you have the option to kind of do both ortho and perspective views of your model. Let's go through a simple example. So we'll go ahead and in this first example, so here, similar to what I just mentioned in the previous slides, you will have started with your Adapt ADM file. So we can see here this is 70 megabytes. I would have exported the INP file. We have the MAT VXF, which is the actual Visicon file. We're going to start this by just opening up the INP. So this now has opened our Adapt model in Visicon. We're going to go ahead and clear any warnings, open up the maximum screen, and we'll just kind of go through some of the options you have to create. Again, here the focus is just to create 3D graphics. Under visibility, we're going to turn off our loads, so you have very easy access. For example, if I want to turn off all my slabs, etc., I can just quickly do that. If you don't want to see this grid background, we're going to turn this off. We can also change the color of the screen, let's say that way, and we're going to turn off the sky. So here we have a very clean 3D model view. We have our orbit. We're going to turn off our orbit, and we're also going to turn off our insertion point. So this icon here that you see at the left is our insertion point, and we're going to turn that off. So now we've completely cleaned up the model. We have some simple options here. This is in colorize mode down at the bottom. You can see based on component type. We can also colorize based on material color. So here, this could be, let's say, one of the first screenshots that we can take. I can also then come in, right-click, select all of the slabs, right-click, and say make those transparent. So this is a nice screenshot that would, for example, allow you to show how you have all your tendons and rebar placed. You can zoom in and you can see very nice details of all the different components in your model. We're going to zoom out. We're going to use now the level mode. So we're going to go to Home, Enable Levels. So you see this automatically splits it into, this is the lower level, or we can go up one level, and this is just isolating the podium level. I had mentioned the ortho mode or not, so this is a simple ortho mode, so we can go from the top. So this gives a nice view of the model from the top. We're going to go back into orbit and look at it from this perspective. Last thing we're going to do is look at our clip planes. So we can, for example, if I want to zoom in, I select any surface, right-click, add a clip plane, and this allows me to come in and nicely cut a section. So for example, here I want to illustrate that we have these thickenings in our slab. If I want to isolate that core wall, again, I select the surface, right click, add another clip plane, and this is how I can maneuver and isolate as much or as little of the model as I want. So this gives kind of a good overview of how you can use Visicon to prepare your model and create really nice screenshots for your reports. So let's close this out and go to the next part of the workflow. So the next part is, how do you share your model? And here really the scenario we're talking about is you run into situations where people say, hey, you're doing all this work on this adapt model. I'd like to see the adapt model. I want to understand better what you're designing. And obviously, A, the people don't have an adapt model, and B, you don't want to give away your actual raw design model information. So this is a good alternative. What you can do is you can save your model as a Visicon VXF file. It becomes a tiny file format, similar to what we were looking at before, right? The adapt original model is 70 megabytes. The INP, which is the exchange file format that Visicon opens, is 2.8 megabytes. By the time you open it in Visicon and save it as a Visicon VXF file, it's only 125 kilobytes. This can be easily emailed to somebody. And most importantly, they can open this version of the adapt model without needing a license of either adapt or Visicon. They can just go to our website and download the free viewer. And it's no risk to you. You can easily distribute your adapt models, show off what you're doing, all the great work, allow other people to understand and coordinate their work with your design without having to them having a license, or you risking them being able to reverse engineer anything you've done. So what's the third benefit? The third benefit is that you can use Visicon to help coordinate some of your actual models that you use in your office. So let's say the scenario is that you have at some point in your project development process, you may have a Revit model, you may have an ETABS model. If you're using Tekla, you have IFC models, and you're building your various adapt builder models. And so the question is, how well are those still aligned? So really what we're talking about, using Visicon to merge these various analysis models or BIM models, whether it's merging adapt with Revit, merging adapt with your ETABS model, merging adapt with your IFC model, and then using that merged version to really find any discrepancies and make sure that your assumptions are all aligned. So let's go through a simple example. We're going to go here, we're going to go to coordinate model. So here in this folder, what we have is we're looking at, this would have been the original Revit model. I've created a VXF, so the Visicon version of it. I would have had my adapt model. I created an INP file. And to save time, I've already merged and aligned these two models, so we'll just go ahead and open up that version right here. So what we're looking at is, this is now our merged model. On the right side, I open up the project browser, and we can see under levels, under models, this is the Revit model, and this is the adapt model. And you see I've merged in and aligned the adapt level 5 model with my Revit. I'd already gone in and created a particular view, which is isolating using the clip planes again, level 5. And I zoom in and I can see that at this location, my wide shallow beam, the gray in adapt, is actually modeled wider, so it's stiffer than what I have modeled in my Revit model. So this is an indication that I need to go into Revit and update my Revit model to reflect the latest concrete design. Otherwise, we can kind of zoom around in the model here and can see there's small discrepancies in the slab boundary that might be less significant. We can see there's some changes or differences in the openings. So here, both models have an opening, but they're slightly offset. Again, I could maybe live with that. And here are examples of openings in our pink Revit model that are not reflected in the adapt model. Again, it may not be important, but but this is an easy way for you to be able to identify those discrepancies. Most importantly, I can be happy looking at this model that my column and wall alignment is actually pretty good. So in this case, I can with confidence say, you know, my adapt analysis model reflects what I have shown in my structural drawings that's driven off of Revit, and I just maybe need to make a small adjustment to those wide shallow beams. Let's go to the next workflow. So the next workflow addresses using Visicon's checking rules to be able to isolate and highlight or interrogate your model based on specific characteristics. I always bring up the example of like sending your luggage through the TSA X-ray machine. The the TSA officers are able to, within seconds, determine what's the content of your luggage, whether there's, you know, something good or bad in there. And they do that by putting different contrasts on the, you know, the different densities of materials in your model or in your luggage, and kind of the same principle can apply here through Visicon. So imagine you're now taking your Visicon model, you're going to run it through Visicon, you're going to apply these different filters or screens, and you want it to highlight anything that could be a potential discrepancy. Or you're going to use the same capability to communicate to others how consistent and uniform, or let's say compliant, your model is to what the design intent was. So here, what we're talking about, using validation rules to colorize any design characteristics to either improve your internal communication or how you communicate your project information to others, or simply as a way for you to do internal QA, QC. Let's run through a simple example. We're going to go open up this folder. So in this case, again, we would have started out with our adapt model. I've exported it as an INP file, and we're going to open up, actually we can just go ahead and open the INP file. This is exactly where you would start out. We're going to clear the message, and so here's our model. I'm going to start by just highlighting how variables and rules work, and then we're going to apply some pre-saved templates. So we're going to go to visibility, turn off our loads. We're going to select a column, and I'm going to show you how you can use validation rules to interrogate your model. What we're going to do here is we're going to come down and we're going to say we are interested in knowing what is the compressive strength that we've assigned to various components, and do they differ, right? I just want to check. Let's say I'm the project manager. And so I look down and I can see there's a core material. I right-click any of these variables or properties. I copy the variable. In this case, I'm interested in the concrete compression strength. I select that variable. I come to my rules. I'm going to create a new rule. We're going to use the uniqueness function. I'm going to paste that rule. So we want to check the model for the uniqueness value of core material compression. And here you can see that my columns are all assigned uniformly one compression strength, and my slabs and walls a different one. If I select this column, I can see that the column is concrete 2. If I go to the material list, I see concrete 1 has and I'm going to switch the units to imperial, has a compression strength of 4 KSI, column 2 of 7 KSI. So you could check each one individually, but really the benefit of a rule is I can take any model, doesn't matter how big or complex it is, I can apply this rule and immediately do a quality control and interrogation and be very clear about how many different material strength assignments I have applied. So this is how a rule is set up. But you can also make this more efficient by going and saying, storing predefined rules. So we're going to apply those. We're going to go to File, Apply a Template. So we're going to apply a set of rules that I saved called Adapt Model QA. So I'm going to apply this. And so what we're doing here now is this goes in and, for example, this identifies, so some of them are checking based on area force of dead loads and other parameters. I'm going to turn on our loads again because we're going to do some quality control on our loads. I'm going to select this area load rule set. So what you see here is this uniquely color codes all of the applied live loads. I can see that I have two types of live loads applied here. So this would be a live load of 40 pounds per square foot, and then I have superimposed for the corridor 60. So I can now with confidence know that for my typical levels, because I can see that I have this uniformly applied, that I have the 100 pounds per square foot of cumulative load in the corridor areas and 40 pounds outside. I can see there's a different loading here below, so I select this, and this is at 100 pounds per square foot live load. So again, bottom line, I'm using these colorization rules to quickly isolate different characteristics of my model. We're going to do the same check for our area dead loads. So here I can see that, where I have uniform patches. We can do this for our line loads. So again, I can verify, should I have different line load here where it's pink versus blue? We can isolate various slab thicknesses. So here I can see that this is a green load right there, and this is 7.5 inches. This is a 7-inch slab, and all of the blue ones are uniformly 8 inches. We can look and apply the same thing for wall thicknesses to check for uniqueness. Here I can see a difference between, this is 12.19 inches, this is 12.207. This must have been a modeling round-off error. I can live with that. I'm now coming in and applying the same kind of rules to my column parameters. And lastly, we're going to apply a rule that has checking the floor-to-floor height. So I can see uniformly at this level, all columns and walls are assigned the same height as I would expect. Then I have another set of heights, and then at the roof level, a different height. So in conclusion, I can use these checking rules to very quickly apply filters and colorizations to my models. We'll do one more. We're going to go to Apply Template, Slab, and Wall Colorization, just to show how this works so easily. So again, these are different rules that apply. I can then come in and we're going to turn off our loads. This applies then uniform color strategies to my critical components. So let's go ahead and close out of this and move on to the next workflow. So the next workflow talks about how you can use Visicon to generate 3D BIM tendons from your ADAPT models. Why would you do this? Is so that you can show your PT designs in a more realistic geometric layout. And I'm not promoting here that you as the structural engineer become responsible for the final coordination and actual placement of the tendons. However, we run into so many instances where what an engineer is proposing as a theoretical force, or just, let's say 21, 25 tendons in a band. That way, what Visicon allows you to do is at least order of magnitude allow you to quickly see really how much area does that take up, and is this something that may cause or trigger constructability issues. So it allows you to be able to validate constructability at an early stage of the design and be proactive in engaging in BIM coordination by either sending your ADAPT model with the 3D tendons to the contractor or whoever is doing the BIM coordination, or to say, hey, send me information. I'm able to do just a quick order of magnitude coordination and give you a comfort level that what I'm proposing will work. So let's go through a simple scenario. We're going to come in and we're going to start out by looking at a model where everything has already been laid out according to multiple disciplines. So in this particular example, what we're looking at is a scenario where we've combined the Revit structural model, the tendons from the ADAPT model, plumbing from the a mechanical, and we've merged all of these together, and I believe we even have a 3D embeds that if we look at this corner, we can also see the 3D embeds that are also in the project. So what we're doing here is, an example of where we've merged all of these, and you as a structural engineer can then quickly run a coordination to determine whether your design is going to cause conflicts or not. We can also run clash detection, and so here's just some examples where the program has identified where the mechanical sleeves may clash with tendons. So let's go ahead and close this out and go through an example of where we're taking a raw adapt IMP file, so this would have just been exported from adapt, and see what configuration options you have. So we're coming in here, we're not interested in loads because we're just looking at the post-tensioning, and what we're going to do is zoom in. We're going to do the same thing as before, where we're going to take the slab, select all the similar slabs, right click, make those transparent so that we can expose our tendons. And what I want to show you is that if I grab this tendon here, so we use tab, so I've selected my tendon, what I can do is I can, for example, adjust what the spacing of the actual, so this is a more realistic distribution of, let's say, my individual tendons, so that I can model the width of my band. I can also, if I scroll down, access each of the tendon ends. So here we're looking at the orange end. I can, again, I'm going to switch my units to imperial. I can do things like see, would this work if I put it into 2 rows? Okay, that could work. I can make these horizontal, place them horizontal. Well, actually, we'll keep them vertical, and we're going to change the spacing, let's say, to 5 inches. So this could work. It looks to me like there'll be enough room to accommodate whatever reinforcement will finally be there. So again, the purpose of this is to give you an order of magnitude degree of confidence that yes, the number of tendon anchors you're proposing may be able to work, knowing how much rebar you're also designing at that location. Scrolling down, we take this scenario here. We're going to again use tab to select this tendon, and we've already done the vertical to horizontal, and this allows you to play with things like where you're actually splicing or splaying the tendon. So again, in conclusion, this is just a very effective and easy way for you to be able to take your adapt design models and quickly create something that is more actionable from a proactive BIM coordination perspective. Let's go ahead and close this and move on to the next workflow. So the next workflow that we're going to address is using Visicon to manage changes. There are many ways that Visicon allows you to manage changes. We're going to focus in on specific adapt model scenarios. So what you can do is there are different things called operations that allow you to clearly identify changes between adapt model versions. We can drill down into changes on geometry, quantities. So that scenario could be your client wants to know what happened between the the SD and the DD phase. How much did concrete change? How much did rebar change? How much did my post-tensioning change? Of course, you can run adapt quantity report for each instance, but what Visicon allows you to do is merge those two models, run a variance check operation, and it will graphically show you where the changes happened and quantify that for you. So it's just a much more effective and smarter way of communicating those changes to your clients. We're also going to, not only the geometry quantities, as well as any other property. So let's start by showing what it means to identify the changes between any property. So here we're going to go here, manage changes. So we're going to first open up a project where we have merged 2 models. These 2 models are identical. If we open up the project browser, we can see that this is model 1, model 2. As far as we're concerned, they're the same. So what's the difference? Let's say I'm a project manager and I'm concerned to see, did we change material strength anywhere, right? Because let's say the original design wasn't working, so we've gone back, we made some changes, we didn't change geometry, but we increased strength, and we want to communicate to our client where exactly we made those changes. So in this case, what we do is we go to operation, we have clash test operations, which were used to do the tendon sleeve check, clearance check, which we're not going to go through, Boolean difference, which we'll do next. This is now running a variance check. So we would have created a variance check operation. This variance check operation we configure to test against a variable. And the variable we want to check is the core material compression strength. Again, the same variable as we extracted before. We run this. It has identified 3 locations where there's a change. We look at the individual issues. And when we come here, we see that each one of these is listed, where it highlights where in your ADAPT model it changed, and it quantifies exactly what the change was. So here it tells you that you have a variance of about 13.8 megapascal, where it changed from 27.6 to 41.4. And so that way it takes away all the mystery and guessing of where you've made changes. And what I want to highlight here is that you can apply this and fine-tune this operation to pick up any specific parameter that is non-geometric or geometric in your 2 versions of ADAPT models. So let's close out of this and go to the next example, which is a 3D Boolean difference. So in this scenario, we have 2 versions of an ADAPT model. And now I want to review this with a, let's say the project engineer, and I say, tell me what changed between your last version and this version. Instead of spending, leafing through PDFs or anything trying to explain what happened, I simply merge the 2 versions of the ADAPT model in Visicon, run what's called the Boolean difference operation. So let me show where that is. So that's under operations, Boolean difference. Similar to the previous operation, it would be listed here. It's configured to check project version 1 against project version 2. And it runs, we run it, it has found 34 instances where these 2 models have changed from a physical perspective. What we're looking for is color. Green indicates that we have now added something in the new version, and red means it was removed. So in this instance, the tendon, this band, has been moved slightly from the right to the left. I see some color here. We zoom in, and if we look in, we can see that that tendon was actually, the drape was moved from up to bottom. So again, these are subtle changes in the model that might go undetected, but I can use the 3D Boolean test to clearly identify where those changes are. Otherwise, I see some additional green here. If I zoom in, I can see that in this case, if I'm the checking manager, I can see that the project engineer has added 2 tendons to each of these bands, probably to, then I can go back and say, why did you add these tendons? And the answer could be because of, dead load balancing or stresses that weren't being met. But at least I can quickly identify where those changes happened. We're going to use the notion of a clip plane again, isolate the lower half of the model, and here we can see, yes, there are some changes in footing size. We see some green here. I'm going to double click on the wall, rotate around the wall, and we can see that this wall was made wider, and I have some changes in the rebar below. I see that a couple of the bars were reduced, probably because the wall got thicker. We didn't need as much rebar. And I can see here there's some changes in the rebar design on the right side as well. So in conclusion, you can use the variance checks or the 3D Boolean to really dial in exactly what you're looking for as far as changes between any 2 versions of your ADAPT models. So let's close this out and go to our last workflow. So the last workflow is really the simplest, and that's just to say, instead of making screenshots of your models and marking them up in blue in a PDF, go ahead and just simply use the model itself and create annotations directly on there. That way you're not losing the 3D context that's really underlying your annotations. So again, this is to be able to work smarter by annotating your models directly and getting coordination issues resolved faster. Let's go through a simple example. We're going to open up a project. Again, here, we're going to open up the native adapt exchange file, which is what we would have exported from the program. So this is a large podium project. We're going to again turn off our loads. We don't need those. I'm going to switch my color mode to the material color. I just prefer doing my markups in this mode. If we zoom in to this area, what we can do is I'll first demonstrate, and let's say I don't want to see that orbit widget, so I'm going to go ahead and turn that off. We can go to our views and or let's do measurement. We're going to go ahead and create our first measurement. When we create annotations or 3D markups, it's asking if we want to create this on our default view or if we want to create these on a new global view. The advantage of having independent markups on each view, it's like having a separate screenshot that we can then run a report on as well. So in our case, we're going to go ahead and create it on a new global view. And so now we can come in and, let's say, measure the distance, and I'm going to switch to imperial units. So the distance here is 10.65 feet, and we can contrast that with the clearance and the headroom that we have on the right side as well as on this side. So you have the ability to create lots of different measurements, surface areas, angles, lots of different ways to be able to generate different measurements on your model. So these are measurements. Let me go ahead and just do a linear measurement here as well, and then you can pick and choose to have all of those independent axes displayed at any time. You can also come in and for each of these dimensions add comments directly. So if I come in here and say, for example, increase to 11 feet and choose to show the comment all the time, I can now have a comment that is permanently displayed on that measurement. We're going to go ahead and create a new view, and this time we're going to now use our annotation. So we're going to go to views and markup. First thing we can do is just provide an annotation like this. So here we can come in and provide any text. You can customize the look and feel of those. So we're going to come in and let's say I want my text color to be white. I want my fill color to be something, let's say, that will be a little more dramatic, and reduce my transparency. And in this case, I'm going to actually come in and change the text color back to something darker and make the font size smaller as well. All of these annotations, you can come in and readjust at any point. You have the option of multiple, 3D annotations as well as any. So these are 3D or 2D annotations plus a combination of 3D markup. So for example, here this is a spot elevation. Any of these markups that you make, you can then come in here. You can either, as we discussed, share the Visicon VXF file, or if you prefer, you can give each one of these views a name. So this is going to be, my title A my title B. So this is giving each of the views a name. We're going to go to our reports and generate a views and markup summary. You can determine the size. So we want the screenshot to be 1000 pixels by 800. And so you either share the Visicon file, or for somebody who does not want to view or interact with your markups in native 3D format, we've gone ahead and just created an actual PDF version of our report. So this nicely has all of your markups in here that makes it very easy and effective for you to be able to communicate any changes that you want to make on your adapt models, or any coordination that you're trying to do. A very effective method of disseminating that information. So we'll go ahead and close this off. Perfect. So we've now covered 7 simple methods that allow you to get more out of your adapt models using Visicon. You can always learn more by going to our YouTube channel. Just enter Visicon BIM and it'll take you to our channel where we're constantly uploading new videos. Again, thank you for participating in today's webinar. You can contact info@visicon.com or sales@adaptsoft for pricing and licensing inquiries. Thank you.